Hi everyone. This recording is for lab 3 and 4. Okay. We had certain configurations done during lab 2. That video is already shared. This is in the continuation of lab 2. You can go ahead and resume from lab 2 to continue lab 3. Okay. In order to perform the labs, you have to log into labs.networkgeek.in, use your credentials, then based on your native console or browser console, you can select whichever is suitable for you. Click on sign in. Once you sign in, you'll be able to see your folders, navigate to PaloAlto Bootcamp and Lab 3. Click on open. uh, Now, as I said, we can resume from Lab 2. You'll click on import config and you can select import. This will import your configurations that has been already done during our lab 2, right? Let's go ahead and start the firewall. Let's start this router, the management PC, and a LAN PC. Okay. Okay. All right. Uh, Meanwhile, these machines are booting. Let me just give you a review what has been done till lab 2. In the lab, till the lab 2, we have configured IP addresses on Ethernet 1/1. The IP address was 10.1.1.2. The IP address on Ethernet 1/3 was 172.16.1.1. This interface was acting as a default gateway for the LAN. So this machine over here has an IP address of 172.16.1.2, and default gateway, we are pointing it to 172.16.1.1. This is our management PC with an IP address of 192.168.1.2. And this is, as usual, our ISP router, right? We don't need to touch anything over here. In lab 2, we have created a security rule to allow the flow from this Windows machine towards the internet. The security rule was allow internet. Anything coming from trust going towards untrust had an action of allow, right? In order for this traffic to go out to the internet, we have performed a NAT over here on this firewall. So NAT rule, that is default NAT, was configured. Anything coming from trust heading towards untrust, NAT it to the interface IP address of Ethernet 1/1, that is 10.1.1.2, right? We have done a dynamic IP and port over there. In today's lab session, we are going to discuss about the NAT and types of NAT for the source NAT translations and the interface management profile, right? Let's see if the devices are up. Okay, we have a prompt PAVM login. Let's see if we are able to log in. Admin test at 123. You can use the credentials which are mentioned over here in the lab itself. It's showing login incorrect. I think it will take a couple of more minutes before we are able to log into the firewall, right? In the meantime, let's verify the IP address on this management PC and your LAN PC. So that let's log in. The password is welcome, which is already mentioned on the lab. You can always identify which machine you're logging in based on the name. You can see in the bracket OOB management. So this is my management PC. Okay. Let's check the IP address for this management PC. So 192.168.1.2. I have not assigned any default gateway, or neither I have assigned any DNS. Okay. If in case you do not see uh, any IP address over here, if you do not see any IP address that is assigned to this management PC, please go ahead and assign these IP addresses as 192.168.1.2 and the subnet mask as 255.255.255.0. Click on cancel, close, right? Let's validate if we are able to log in. Let's see. Admin, password is test at 123. Right, so we are able to log into this machine now. Okay. Now, in order to verify if it has the configuration, let's wait. Okay, so now we have the prompt. You can run the command show system info, and you can see the IP address that is assigned is 192.168.1.1, and the mask is 255.255.255.0, right? We don't need this CLI. If in case we need CLI, we will take it from the management PC itself, right? By doing an SSH. Let's close this. Uh, let's try to access the GUI. HTTPS :// 192.168.1.1. Enter. This is the GUI. Admin test at 123. D capital. Login. Let's quickly validate if those configurations are already present on the firewall or not. Allow it a minute while it loads. Okay, we have the dashboard. Let's close this. Let's see the network interfaces. And if you navigate to the Ethernet, you'll be able to see Ethernet 1/1, which has an IP address of 10.112/24, and the security zone is untrust. Ethernet 1/3, the IP address is 172.16.1.1, which is a default gateway for the LAN, and it is in the trust zone, right? Uh, let's see the zones quickly. So trust and untrust, these are layer 3 zones that we have already seen. If you go to virtual router, you'll be able to see a default route that is added to send all the traffic through the interface Ethernet 1/1, because that is connected to your ISP. Let me open the default route. You can see the destination 0.0.0.0/0. That is everything. The route is pointing to Ethernet 1/1, and the next hop is 10.1.1.1, which is the ISP router. Let's click on cancel. Let's quickly verify the policies. So if we come down to the security rule, you will see we have created a rule which says allow internet, anything coming from trust, heading towards untrust. The action is going to be allow, right? Similarly, if we verify the NAT rule, you can see the default NAT, it's just a NAT name that we have given, default NAT. And anything, the source zone coming from trust, any machine which is there in trust, and heading towards untrust, we have selected destination interface as any, and service as any. And we are doing a NAT translation, dynamic IP and port, that is DIPP, that we have discussed in lab 3 and 4, right? Oh, sorry, day 3 and 4, will be NATed to interface Ethernet 1/1 IP address of 10.1.1.2/24, right? So this is the NAT rule that is being configured so that this Windows machine is able to reach out to the internet. Let's verify if we are able to reach out to the internet or not. Welcome. And okay, if you do google.com, so we are able to reach out to the internet. However, if you see, we will not be able to ping the default gateway. Ping 172.16.1.1 is the default gateway. We will not receive any reply from the default gateway as of now. The reason for that is we have not assigned any interface management profile. So by default, every traffic that is headed towards the interface itself, right? The interface which is on the firewall, those packets will be dropped, right? In order for the reply packets to come back to the Windows machine, we need to assign interface management profile. Okay, let's go ahead and do that. So in order to configure an interface management profile, you need to navigate to network. Under network, you'll see network profiles, interface management. Click on add. You can give it a name that makes sense to you. For example, allow dash ping dash https dash ssh, right? So it gives you the detail, right, that the ping https and ssh is allowed. Select https ssh ping. We already discussed about the permitted IP address during the class, that this acts as an ACL. What the IP addresses that you add over here will only be allowed to access these services. For example, if I add 172.16.1.2, only that particular machine will be able to do ping, SSH, or HTTPS. Rest of the machines will not be allowed to do ping or SSH or HTTPS on the interface where this interface management profile is applied. Okay, let's click on OK. Once this interface management profile is configured, you need to navigate to the interface. We want to apply this profile to 1/3. Okay. You can navigate to advanced and management profile. Under drop down, you'll be able to see allow ping HTTPS SSH. Select the profile that you have configured. Click on OK. It will give you a warning. Click on yes. Commit. Commit. We'll have to allow it a minute to commit the changes. Right, the commit is almost done. Okay. So the configuration is committed successfully. Let's go to our Windows machine. You can see this is Win2. This is the machine, right? And the IP address that is configured is 172.16.1.2 and the default gateway is 172.16.1.1. Okay, let's try to ping. So earlier we were not able to receive any response. Now we are able to receive the response because we have attached the interface management profile and we have allowed the service ping, right? Uh, let's try to validate if we are able to do the HTTPS and access the GUI of the firewall. Please be mindful that you are not going to access the GUI using the management interface IP. Rather, we are going to use the Ethernet 1/3 IP address. So 172.16.1.1, that is the IP address on in Ethernet 1/3. Let's see if we are able to access the GUI. Yeah, looks like we are able to uh, enter your credentials. Just validate if you are able to log in. Admin test 3. right? So the credentials are working. We are able to log into the firewall. In the meantime, maybe we can check if we are able to do the SSH, right? So because we have enabled ping, HTTPS, and SSH. Let's see, 172.16.1.1. Click on open, admin, test at 123, test at 123. All right. So the login works. We are able to log into the firewall's CLI from this machine, which is your LAN machine, because we have exposed the Ethernet 1/3 interface to ping, SSH, and HTTPS, right? We are able to browse the GUI of the firewall. So things are working, right? So that is about your interface management profile. Now, let's go ahead and configure the labs for your NAT. There are three types of NAT that we have looked into our class. First one is your DIPP, that is dynamic IP and port, which is nothing but PAT in simple terminologies, that is port address translation, wherein we translate the IP address and the port, right? Uh, then the second one is dynamic IP, wherein we provide a pool of IPs, right? And that creates one-to-one mapping, and the pool should be sufficient so that all the machines in your LAN should be able to reach out to the internet, right? For example, if you have two IP addresses in the dynamic IP pool, and you have like four Windows machine in the LAN, then only two machines will be able to reach out to the internet because only two IPs are available for the NAT. In dynamic IP, we do not touch the port, right? There is no modification of the port. And then static IP is like one-to-one configuration, wherein there will be one IP address that we assign for the translated packet, and there will be one IP address that we select for the source address, and always that particular IP address will be NATed to the IP address which is selected in the translated packet, right? We can select it as bidirectional. Bidirectional will make it work in both the directions for inbound as well as outbound. So wherever there is a traffic originating from uh, untrust and coming down to the IP for which we are applying that static NAT, it will do the NAT for that traffic as well, right? So no worries, we'll go ahead and have a look at that. We'll close. Let me close this. Let's go back to our management Windows machine. So this is my management. We'll go ahead and configure. So before we do that, we can have a look at the traffic logs to validate. So let me. I'll do one thing. I'll add and remove few columns so that it becomes easier for us. We don't want source user. We don't want dynamic address storage. We don't want this. We want to see NAT IP addresses. So NAT source IP, NAT source port. Okay, great. We can remove source dynamic address group as well. So what I'm doing is just to, clean up the log so that it becomes more readable, and we can do an adjust columns, right? So this becomes a bit more readable. Now if we see the traffic that originated from 172.16.1.2 uh, is getting NATed to 10.1.1.2, right? Which is your interface IP address. This is your NAT source IP, and this is your destination 888, right? So we are applying the NAT, that is the source NAT right now. You can see the details of the logs by just clicking on this glass icon. Okay, so we can see the detailed log view. Here you will be able to see the source IP, that is 172.16.1.2. You can see the port 54191. This is the source port, and we are NATing it to 10.1.1.2 IP address, which is your Ethernet 1/2 IP address. And the NAT port, we are NATing this port 54191, and we are translating it to 53534, right? This is the source section. The packet was received on interface Ethernet 1/3. Do not get it confused with the NAT interface. Okay, we are NATing the source to the Ethernet 1/1 IP address, which is 10.1.1.2. Okay, this is the destination column where the packet, which was aggressing. The destination was this IP address, that is 142.250.77.164, and the interface through which the packet was sent out was Ethernet 1/1. And you can see we are not doing any kind of NAT on the destination, right? So we are just doing a source NAT. All right. So I just wanted to show you the logs. You can quickly have a look like what rule it is taking ahead and what was the action that was taken, and these details, right? Let's close this. Let's go ahead and configure the uh, NAT rule. So we can see the NAT rule is already configured for your Ethernet 1/1. Let's review this once again, right? So the general tab will have the name as whatever name that you'd like to give. I have given it as a default NAT. Description, again, any description that makes more sense when you read it about this rule. You can assign the tags to sort of like organize your NAT rules, right? So there might be a group of rules which might be applying to a similar type of traffic, and then you can arrange those rules based on the tags, and then you have this option group rules by tags, right? Then we have NAT type, which is IPv4 and NAT64 NPTV6. IPv4 is, as usual, it is applied to IPv4 traffic. NAT64 is when you have disparate system wherein IPv4 is going to IPv6 system, or IPv6 is going to IPv4 system. In that case, you can use NAT64. And NPTV6 is when IPv6 to IPv6 NAT is being done. In that case, you can use NPTV6. Let's go to the original packet. Again, original packet says source zone as trust. Any machine which is there in the trust zone trying to reach out to untrust zone, right? That is your internet. And right now I have set the destination interface as any. We are not changing these parameters, right? And the service, which is the port number, is any. So any traffic originating from trust heading towards untrust will be NATed. I have not specified any source address and destination address. That means it applies to all the source address heading to any destination address. Okay. Translated address, currently it is set to dynamic IP and port. As I've said, this is nothing but PAT. Currently the address type is interface address. So we are NATing it to Ethernet 1/1 IP address, right? Which is 10.1.1.2. There is another option that is available over here is the translated address. Once you select the translated address, you will get uh, a block where you can add the IP addresses. You can assign the IP address. This will act as a pool. So for example, I'm adding 10.1.1.3, 10.1.1.4, right? So these two IP addresses I have added in the pool. Now, please do take a note that dynamic IP and port means this will have this will also so if it is getting NATed to 10.1.1.3, we are also modifying the port number, right? So we will have sort of like, if you generalize the calculation, 65,000 translations for 10.1.1.3 and 65,000 translations for 10.1.1.4, right? Uh, I am not taking into consideration well-known ports and these kind of calculations. It's a very generalized one. So if you see 65,000 for 10.1.1.3, 65,000 for 10.1.1.4, right? Let's see if this is working. Click on OK, do a commit, do a commit. And let's see if we are able to access the internet. Let me turn this machine on as well. And this will have an IP address of 172.16.1.3. So let's verify if we are able to reach out to internet. Okay, before that, let's see if the commit is successful. So the commit is still pending. Let the commit go through. All right, so we can see the commit is successful. Let's close this. Let's verify if we are able to reach out to the internet. I'm on Win 2, that is this Windows 2 machine. Okay, let's hit enter google.com. This is working. Let's see youtube.com working. Facebook.com is working. Let's see the logs on the firewall. Right, we can see the commit is successful, right? Let's go ahead and check if we are able to see the logs. So we can see the NAT source IP is now taking 10114, right? And for some of them, it is taking 10113, right? That means NAT, yeah, 10114. And you can see the port is also modified. That is 29910. The original source port was 62834, right? So this is essentially doing a pat with the IP addresses configured in the pool. So I guess this clarifies the DIPP, right? Wherein the first option we have configured it for interface address. If we come here and we can see we have configured for interface address that has been already tested in the lab. Then we went ahead and configured the translated address wherein we add the IP addresses to the pool. Translated address 10113, 10114, right? And we were able to verify this from the logs that the IP that is taking a hit is 10114, and we are also modifying the port, right? Now let's go ahead and test the dynamic IP, right? As I mentioned, dynamic IP also creates one-to-one mapping. However, there should be enough IP addresses in the pool. So 10.1.1.3. Let's just give one IP address for now to test. I'll click OK and do a commit. And in the meantime, so we have started two machines at this time, right? So there is this Win2 and this is Win1. Okay, let's get the GUI access for this as well. Let me log in. Let's see if the IP address is assigned. So I have assigned 172.16.1.3 and the default gateway is 172.16.1.1, right? Uh, let's see the commit. It's still going on. We'll have to wait for the commit to finish. In the meantime, we can see this internet is working. We are able to access this on Win2. Uh, let's see what happens after the commit is successful. Okay. Okay, so the configuration is committed successfully, and you can see we just have one IP address that is 10.1.1.3. And as we have mentioned during a class as well, dynamic IP is not going to touch the port, right? We are just going to translate the source IP to this 10.1.1.3. Okay, let's verify. So this is my first machine. I'll try to access. Let me close these pages and try to access yahoo.com, uh, cnn.com. Okay. So these pages are loading. Let's try to see if we are able to access it from other machine. This one had 1.3. Let's click the browser. Mm, close. Let's see if we are able to access it. Google.com, youtube.com. Sorry. youtube.com, facebook.com. You can see these pages are, not loading. They are, you can see no internet, no internet, no internet, right? The reason for this is, you can see, let's go to the monitor. You'll be able to see that 1.2 is getting natted to 10.1.1.3. Like, let me do a refresh. So 172.16.1.2 is getting natted to 10.1.1.3. Now, because this IP pool is already exhausted, there is just one IP address in the pool. So when the traffic is coming for 172.16.1.3, there is no available IP to NAT the traffic, right? And because of that, the packets are getting dropped before even the session is created, right? Let me see if we are able to see it here in the session browser. No, right? Because the packets, uh, when the packet reaches to the firewall, and there will be a route lookup, there will be a NAT lookup, and during the NAT lookup, the NAT has to be applied, but there is no IP address in the pool, and the packet gets dropped, so there will be no session created, and because of that, you will not be able to see any of the traffic. Okay, in order to see if if adding another IP in the pool will make it work, let's go ahead and see. We can add translated packet. Let's add another IP, 10.1.1.4. Click on OK. Let's commit the changes. Commit. So still the same behavior you are observing, right? Because we are still, the commit is still to be applied. Okay, we are able to access internet on this machine, which is your Win2. This is working, and we are not able to access internet over here because the NAT pool was exhausted. Let's wait for the commit to be successful. You can see the commit is successful, right? And let's go ahead and check if you are able to access the internet on the second machine. Now you can see the page is already loaded, right? We were facing issues with the internet. Let's try to refresh. Let's try to refresh. Your YouTube is loading. Your Facebook is loading. Let's try to see if the internet is working on the first machine. Let me try to open a new page. Twitter. Okay. So Twitter is loading. So now both the machines are able to access the internet because there is enough IP addresses in the resource pool, right? We have assigned two IP addresses. However, if there is a third machine, it might not be able to access it, right? So whenever we are working with dynamic IP, we need to remember that there is no port translation being done. It is just the IP address translation. So we need to have enough IP addresses in the pool so that all the machines would be able to get their source address translated. Okay. So this was about your dynamic IP. Let's go ahead and verify the third type of it. That is your static IP. Now, as I mentioned, static IP is one-to-one mapping, right? There will be one source and there will be one IP that will be natting it to, right? Uh, in order for that to work, we need to specify a source address. Right now, it is selected to any. When any is selected, that means it's sort of a many to one, and that will not work, right? When you're trying to do a commit, for example, if I give an IP address 10.1.1.5, like, okay. And if I click on OK and do a commit, it will fail right now because it needs an IP address to be assigned so that one-to-one mapping can be created. So we'll go ahead and assign the IP address of 172.16.1.2, which is my LAN machine. I have added this IP address and my translated address is 10.1.1.5. Then we have something as bidirectional. We might not be able to test the bidirectional as of now because in order to test it, we will have to add another security rule so that we'll be able to allow the access from untrust, right? As of now, we just have a security policy that says allow internet from trust to untrust. In order to test the bidirectional, we'll have to create a policy that will allow the flow from untrust towards your trust, right? So we can check this. Let's go ahead and check the static IP first. Let's click on OK, click on commit. Now let's wait for the commit to finish. Now you can say that we have statically configured a source IP address that is 1.2, right? That means my 1.3 will have no natting performed on the traffic, right? We'll see once the commit is successful, my this machine that is having an IP address of 1.3 will not be able to reach out to the internet again, because there is no uh, NAT rule that will take a hit for this particular traffic at this point in time. So this is almost done, 70%. Okay, it says configuration committed successfully. Let's validate. Okay, so this is my Win2, which has an IP address of 172.16.1.2. Let's see if the internet is accessible. It's working. Let me close these tabs and try to open them again. Let's open something like download.com. Right, so my internet is accessible on this machine. Let's see if it is accessible on this machine. Let me close these tabs. Let's try to open Facebook, YouTube. Gmail. I think this page is loaded from cache. Okay, so let's try to open a page which we have not opened. Otherwise, we'll have to clear the cache and see. Let me try to open Twitter and news.com. We can see there is no internet. It's not loading the page. These are from cache. So if I clear the cache, you'll see that these pages are also not loading. This is just taken up from your cache, right? If you'd like to be 100% sure, you can open the incognito window and then google.com and youtube.com. Okay, let's verify if this loads the page, right? So you can see no internet and no internet. That means we do not have access to internet because there is no NAT rule that is taking a hit. We have statically configured that NAT rule to NAT the traffic coming from 172.16.1.2. So no other traffic will be NATed, right? Uh, Everything can be validated by navigating to monitor tab and then traffic, and then you'll be able to see that 1.3 we are there is no natting being done. 1.2 we are statically natting it to 10.1.1.5. You can see there is no natting done for 1.3. And if you see this one, let's open the detail log. So you can see 1.3, there is no NAT being applied because there is no NAT rule actually taking a hit. And because of which, what happens is the packet is being sent out through Ethernet 1/1, uh, but there is no return traffic that is being coming to the firewall, because the IP address that will be sent out will be 172.16.1.3. And then when the ISP router gets the reply back, it does not know how to, send that back to the firewall because it does not have a route for 172.16.1.3, right? So this concludes the lab. Uh, I would highly recommend you to replicate these in your lab and try to validate all the labs by these traffic logs. You can adjust the columns so that you don't have to go to the detailed log view all the time. You can have all the information on your display directly, right? Let me close this. Yeah. So you can add the NAT source port, NAT source IP, destination, and these things, right? You can do so by clicking on this drop down that you see, and then columns, and then you can select what columns you want and what columns you don't want. Okay. And based on that, this will simplify your uh, logs. You don't have to go to the detailed logs all the time, and you can just verify it from here. So you can verify the zones from where the traffic originated and where the traffic is headed, the source IP, if we are applying any NAT, and if we are applying any NAT, if we are doing anything to the port or not. So this is NAT source port, we are not doing anything, this is 0. NAT source IP, for 1.2 we are applying NAT, so you are able to see 10.1.1.5 is the NAT that is taking a hit, right? And this is the port. This is the original port. If you see, we are not changing anything on the port because static IP does not do any port modifications. Okay. All right. So I think let me- all right. So this concludes the lab. If you guys have any questions, maybe we can take it up in our next upcoming sessions, right? That will be on Saturday and Sunday. Uh, thank you.